Welcome everyone, my name is Jat Sarmo. I'm the head of quant development at B2C2. Today I'm excited to talk about how we implemented quant research, quant dev structure with using KX solutions. So quick intro. So I've been in the algo trading space for about 20 years. I love challenges, technology. Before joining B2C2, I co-founded an FX algo trading business for 15 years. We were one of the top players on FX. I joined B2C2 in 2021, a big year for crypto. So B2C2 is the leading crypto OTC liquidity provider. So we provide digital products to the largest institution, retail brokers, exchanges, banks, and fund managers. So data management obviously has been a big part of our journey. There's a lot of real life challenges that I hope to share with you today with some hopefully you can relate to some of those. So the presentation will be about 30 minutes and then 10 minutes Q&A. So let's get started. So over the years, we had many technical challenges, especially around complex, high frequency, trading data, scalability, and speed. So the four areas we decided to cover today are the data, so huge amount of data, sometimes inconsistent sources, high accuracy ingestion. Then we'll move to infrastructure. We'll talk about on-prem versus clouds. We'll talk about how we scale. We'll talk about partnership with AWS and KX. Then we'll move to research, where we'll discuss why do we do research? What's the point of doing research? What we're hoping to get out of it? We'll look at PyKX. We'll talk about Q, and finally we'll move to the visualization of that beautiful data with KX dashboard. Okay, let's see how we handle those. So first challenge. So the interesting thing with data, I think we mentioned briefly in the previous presentation, as opposed to every other industry, is everything is time series. So every trade, every tick, every user action generates a timestamp record. So that makes everything a bit more complicated than in other potential industries. The other challenge is we're going to need high performance ingestion from old AWS regions. I'll talk a bit about the crypto system, but basically we are receiving data from every single AWS region. It has its own complexity, but we need to ingest all that and bring it together somehow. So KDB allows us to handle historical and real-time data, which we'll talk a lot. And then the throughput. So the throughput is how much data I can get through the pipe, as opposed to the latency, which is how quickly I can get it there. And we need both. So we'll look at that as well. And as I was saying, the crypto ecosystem, so all our clients, all our OTC clients, and all the exchanges are in some region of AWS, either in Virginia, in Ireland, in Tokyo. It could be anywhere. There are about 30 regions in AWS. And so we need to communicate between the region. We need to bring the data. We need to save it very fast and replay it very fast. So we'll go through that. And finally, yes, as I said, there's various quality of exchanges. We could put it like that. Some are very professional, some a bit less. So you need to hydrate and you need to normalize that data so you can use it in a simple way and you can provide it to the researchers, not to worry about the data itself. And finally, of course, there's a regulatory aspect that's growing in crypto. You need to save everything. You need to have auditable records. So that's another constraint. And finally, just a quick word on machine learning. I know it sounds obvious because you're all in the same finance industry, let's say, but I think something very obvious that people sometimes forget, it's a bit harder for us because if you look at image recognition, the picture of a dog from 10 years ago is still a picture of a dog today. And it's probably going to be still a picture of a dog in 10 years' time. For financial data, the data from 10 years ago is probably irrelevant. Everything has changed. The frequency of the order book, the participants, you can't really predict the market with some data from 10 years ago. It might be useful, it might give you some insight, but really, you need order data. So I need the data from yesterday to predict tomorrow. So that means that it keeps changing. And also, it's not really reproducible. So I don't know what the market is going to look like tomorrow. I can only infer that in certain scenarios, I'm going to be able to predict what's happening, but I have no guarantee. Just replaying the market won't tell me if my model is good or not. So that I just wanted to mention that. Okay, so data. So it's been mentioned in the previous presentation, there are different types of data, structured, unstructured, streaming, historical, time series. Because KX is a vector-native database, it allows us to handle all of those. So here we try to plot the different types of database. There are plenty. You probably know most of them. But if I just focus on the two famous one, SQL. So SQL types of database. So structured data. I have a table for cars, car description. I have a table with parts, part ID. And then I have a table with car ID and part ID. So car ID 2 has part ID 6, 7, 8, 9. This way I've associated the parts with the car. Very structured, very clean. Then you have NoSQL. So this time let's talk about, a website. You care about a user. You have a user ID, but you don't really want to say what the structure of the data looks like. You don't want to say it's a varchar 255 or whatever. You want to be able to add as much data to that user ID. So you want to add, pictures, obviously lots of information, etc. But you don't really want to structure it. But what you want is access it really, really fast when you give the user ID. So it's a super fast key value store. You can add a second key to search, but that's about it. What I'm trying to say is neither of those are good for time series. There is no way you can do really fast moving averages on either of those. I've tried before to make the SQL one work in my previous company. We tried to build things on that. We managed to get to some kind of throughput, but then at some point it just doesn't work. So that's, without going too much into detail, that's a typical diagram of a KDB implementation. So at the top you have the feed handlers, which we mentioned before. So feed handler for every source. You're going to have a feed handler that you're going to translate into some kind of KDB data. The core piece is the ticker plant. That's the core piece of KDB. It does one thing. It does it really well. It just fires the data to three components. The persistent database, so you got to save it to disk at some point. The real-time database, that's interesting because that's today's data usually. So it's in memory. It's super fast to access. And it's what you're going to use right now. It will get persisted to disk eventually, but the point is it's all in memory. And then the third one, which is a bit less known, is the complex event processor. So this is if you have a lot of mathematical function you want to run on the fly with real-time data coming through and then propagate that. I believe Citadel did a presentation with KX a couple of years ago if you're interested. But anyway, the point is from the user perspective at the bottom here is that you access all that data seamlessly. You don't need to know where the data is stored. You don't need to know if it's in the real-time one, in the HDB. Like everything is transparent for the user through the gateway. Great. So infrastructure. So I like this came from our head of data. So we started many years ago with just one KDB server. It had 256 gig of RAM, but we could still handle 1.5 terabytes per day, which is quite good for one server. And over the years, we had to grow that server. So obviously we went for the vertical scaling. So we just bought more RAM, more CPU, and at some point we got a call from AWS saying, "Look, guys, you bought the most, the biggest one. You have to start thinking horizontally." And so we partnered with AWS. So why AWS? One thing with AWS, it's very easy to spin a new server anywhere in any region, and that's very useful for a business like us. It's very easy to upgrade. In my previous business, I had everything in data centers. You had to actually go there or have someone there. It takes some time to get the parts, et cetera, et cetera. So you have this flexibility with AWS. You can upgrade, you can downgrade. And so the partnership with AWS and KX allowed us to have horizontal scaling, which I'll show in the next slide. I'll show exactly how it's done. I just want to mention that this is actually very efficient. So the partnership we had with AWS and KX allowed us to grow horizontally to ingest many terabytes of tens of terabytes of data per day. And if you compare that to some top hedge funds, I have some, I know a lot of people in the HFT space. So top hedge fund would invest, we're talking $300 million to buy 1,000 servers, put them in, somewhere cold, ideally, like Iceland, because when you have 1,000 servers, you need to think of the cost of electricity. So we managed to compete and to be able to match those huge hedge funds by just having something very, very scalable and very, very efficient. Okay, so I want to talk about that because that's quite important for the way we use KDB today. So there's a product on AWS called FSx for Lustre. I don't know if anyone heard about that. But it allows you to do almost infinite horizontal scaling. Well, it's only limited by your wallet, but let's say, aside from that. So it's like one super fast network drive. I know conceptually when we think of a server with a disk. But here it's a disk made of many servers which have their own disk. And the beauty with that is that it's very easy to, there's no downtime. Every server has its own cache. So it's extremely fast, and you can see it's resin. So for example, file B here is on two servers at the same time. So it's a very efficient way to have an almost unlimited storage, which is then very useful for KDB. One other benefit of that is when you have so much data, file compression becomes important because it's expensive. And that the file compression is done by AWS, which means that you save some CPU cycles for KDB to be able to do some smart stuff and not have to worry about the compression itself. And finally, one thing that we find very useful on KDB, I have some of our research team here, is that you can spin some sandbox very easily. So wherever you are, you can use that same data, and for research that's very useful because we will spin a lot of sandbox where we do all the computation without impacting the production. So that's another advantage. Okay, this is just to explain the various cost versus speed. So here what you see is if you want 1,000 megabyte per second throughput, that's from AWS, you would pay $0.6 per gig per month. Anyway, I'm not going to go through all of that, but the point is that even within the previous drive that I mentioned, you can still choose what kind of throughput you want and how much you're ready to pay for that. Great. So that gets us to research. So the first part I want to talk about is, we talk a lot about research, but for a lot of people it's still very abstract. And the question is, why do we do research? And I've put at the top P&L explained. So the idea is what? I'm pretty sure in any of your businesses, if you ask 5 people in your company how much money we made yesterday, you're going to have 5 different answers. And it's not because people are incompetent, it's just because it's complicated. So in our business, we have to deal with derivatives, with options, with the liquid products, how do you value those, and also the time zone. So when you say yesterday, what do you mean by yesterday? Is it yesterday New York, London, Tokyo? So all of that means that you need something, you need to have a common view of everything you're discussing, everything you're building. It needs to be transparent, so you need to have a common function somewhere that someone can look at and say, oh, okay, so that's how you calculate the P&L, got you, okay. Or I don't agree with that, let's make it evolve. But everyone needs to have the same view and see the same numbers, and that's very important. So a few examples of things we do on the research side. One thing you might know about, of course, or you might hear about is market impacts. So the market impact is when I place an order in the market, how much is the market going to move by? Or when I trade, how much is going to move by? So if I'm buying $1 million worth of Bitcoin, it might be okay. But if I'm buying more liquid assets, and I'm suddenly putting a bid for $1 million of Doge or smaller coins, then that's going to indicate to the participants that I'm willing to buy, and therefore the market is going to move against me. And I'm going to see adverse selection. So measuring that is extremely important. It's the same in all asset classes. Another example is alpha. We talk a lot about alpha. What does alpha mean? You say someone needs to create alpha. It just means getting excess return versus a benchmark. So it means that, for example, stat arb. So you say that Pepsi-Cola and Coca-Cola should technically move it the same way. If one of them is undervalued, then maybe I'll buy that one and sell the other because they will converge at some point. Or it could be that when stocks go down, gold go up, that this is kind of stat arb. And then you have momentum trading where you try to ride the trend. So if the market is going up, I'm going to try to ride it and get some upside there. So there are various things we try to do, but all that need to be measured. And for all of those, we need to do a lot of backtesting. And this comes back to the conversation we had just a few minutes ago, is how long does it take to backtest and how much can you backtest? If you can backtest 3 months of data in 15 minutes, maybe that's good, but how many parameters and how many models are you going to need to test? So it is actually really important that you can backtest a lot and very fast. And we'll talk about that a bit later. So we're talking about replaying months of data at least, and tick data, so every tick that happened on an exchange. And finally, just a quick word on that, because we see that a lot in our industry. Everyone wants to do machine learning, everyone wants to do AI, everyone wants to do the funky stuff, especially at school. All the grads learn all about that. They're really good at it, they're better than us. But what we see less excitement about is building high quality data and CI/CD processes. And for me, it's always the first step. You're going to get the same value doing a linear regression and doing an XGBoost machine learning model if your data is poor. There is no point spending all your time on the model. You have to get high quality data. It sounds obvious, but you also need to measure that. I'm glad you agree. I see there are a few people nodding in the room. And then the CI/CD, so what is that? Continuous improvement, continuous development. So we see a lot of, I'll speak about it in the next slide, but it's all good to have a model that you develop on your own little Python notebook and you think is doing something good, so you deploy it to production, and then what? Like, how do you know if it works? You need something reproducible, and even if it works, how do I come back 3 months later and say, oh, actually, that model that I wrote 3 months ago, it's not behaving correctly now, and why is that? So in the software industry, you're used to Git, of course, you version code, but it's more than code. You need to version the data you trained on. You need to version the data you tested on. You need to version all the performance monitors. You need to version everything so you can go back and say, oh yeah, this is how I got those results. It's not just the code. And I think this is still taking a bit of time to sink into the industry, that it's not just software development. When you start working with models, there are a lot more areas that you need to capture and track and monitor. There was a great talk from AstraZeneca on the process for a new coming up with a new drug in the market, and if they miss one of the performance metric that they need to save, basically it will never go to production. It's extremely strict on every step of the way. How did you get the data? How did you hydrate it? How did you get it to the model? How did you measure the performance? Every step of the way, you need to have some metrics and save them somewhere. Anyway. So yeah, that's the shocking number. It says 87% of data projects never make it to production. That's from 2019. It sounds high, but speaking to some researcher today from various industries, that's only the numbers understated. I think it's a lot more than that. And also, if it does make it to production, then how long is it going to be useful for? How do you know it's still working? So it's back to what I was saying before, but this is from our head of research. Keeps giving us those three very high-level requirements for a good systematic trading system. So you need scalability. So what's that? It means that if you increase the number of variables, or if you include, say, for example, the number of client, instrument, product, it's easy to add a new dimension in your system. That's very important. The second one is integrability. So this is basically downstream. If I build something, if I add anything in there, I don't want to break all the systems that are listening to that. So it needs to integrate very, very nicely. And posterity is the overhead. So we understand, your head of sales come to you and say, look, great news, we're going to have 10,000 more clients tomorrow. Great. And then you think, well, how is that going to affect my system? Of course it will have an impact, but the point is you don't want a big O(n) complexity, you want a log n complexity ideally. So it means that if you multiply the number of clients by 10, ideally your complexity only increased by times 2. And that's very important also in building system. I know all these sound very high level, so let's jump into practice. As of join, I think Ashok mentioned it earlier today, so this is an example we're going to look at how we use a PyKX. So PyKX allows, I'm sure you're going to have much better definitions today through the day, but for us, from our perspective, it allows quant and non-quant basically to access KDB power through Python and Q together. And that's very powerful for us because a lot of us do Q, some don't at all, some are better in Python. But basically, when you mix the two, you get the best of both worlds. So I'm going to explain what the as-of is. I'm sure a lot of people are, so sorry if you already know that. So here we have one table with 1 million orders, and then we have a table with 100 million prices to index. And what we need for every order, I want to know what's the last price that was seen in the market before I received that order. So it's like a join, but it's a bit more complicated because you're not joining IDs, you're joining time. So you're saying, what's the last time before that event? And you're getting to the third table where you have the orders and the index price here. So there is a nice way to do it in Python. And it's called merge as of. You just put the two tables, you tell it, look at timestamp, and it will take the last timestamp from the second table, matching each event of the first table. And that works pretty nicely. And it takes, if you look at wall time, CPU time is how much it took for all the CPUs together. But wall time is what you actually observe. That's 19 seconds. So you'd say it's not bad, because there's 1 million versus 100 million rows. One of them's in memory, one of them's on disk, so it's not bad. But then the queue implementation of that is just, first it's short, of course, and you just use AJ, which is as of join in queue. And to do exactly the same thing in the same PyKX notebook, it takes 100 milliseconds. So that's approximately 200 times faster. So what we're saying is if when you run queue inside PyKX, to do those heavy lifting jobs, it's actually very, very fast. And to be clear, it's not a comparison just, Q is better than Python, etc. It's more to say that if you use Q for the right, problem, you can continue to do all your scikit-learn and machine learning stuff in Python, but at least you saved a lot of time gathering the data. Anyway, before I move on, I promised our head of data that I will mention that there is another framework for instead of pandas that everyone knows. It's called polars. I don't know if you know that. It's apparently 10 times faster than pandas, so I promised I'll say it, but it doesn't change the fact. But there you go. Cool. Do you hear me? Yeah. So next example. This is about showing how we get to high performance with minimal code, and we're going to implement a TWAP. For those who don't know, a TWAP is a time-weighted average price. So it means that if a price is on the market for 10 seconds and the second price there for 1 second, I'm going to weight the first one 10 times more than the second. So for that, what you need is you need to know how long a price has been on the market, which means for a given price, you're going to look at the next price and then compare the two timestamp and multiply that by the price of the first one. So as far as I know, I'm sure there's some Python experts here, but this is the way to write it in SQL. Sorry, in SQL expert. This is the way to write it in SQL. You have to join the table with itself. And then give me the biggest time that's not equal to my time, and then you merge that. So that's how you do it in SQL. In Q, it's literally one line. And the reason it's one line is because you have to remember that Q works with columns, not rows. So while the where statement is probably very similar between SQL and Q, once you're inside the selects, you're actually talking about columns. So you can use this beautiful word that's called next here. So I'm inside my column time. I can say, well, give me the next time and subtract it to this time, which is you can't really do in SQL as far as I know. And then you use the function WAVG to give you the weighted average of that difference for the price. So of course, Q is always as little characters as possible, which is great sometimes, and sometimes it's a bit more tricky, especially on the error messages. But the point is, it's a lot faster. It's a lot easier to read. Great. And by the way, I just wanted to mention for those familiar with function language, and not Q, it's a function language. It means it will be closer to Haskell or anything like that. Great. So visualization. So we've been working with KX for many, many years. And when it came to visualization, we started with the sales team only having an email every day was the performance of their clients, and they had to wait 24 hours, and they didn't have very much information. It was just static. And so we started working with KX, with Sam here, to start building the first dashboard for sales specifically. And they loved it. From day one, they loved it because they could drill into the client form by region, by type of client, by currency, by instrument, by anything. It was very easy to move things around with pivot tables. Everything was dynamic, everything was fast, everything was real time. So it's still successful today. It's so successful that we ended up building hundreds of dashboards across all areas because it's extremely simple and it's extremely fast. And the reason it's fast is because it has a very fast connection and transfer of data with KDB. It's a little bit conceptually, it's probably wrong in an architecture sense, but conceptually it's a little bit like having your UI sitting on a database server. There is no, it's very fast to pull a million data points and display them and then zoom in, zoom out. So we use that everywhere. I think it has about 35 pre-installed components from data grids, pivots, charts, all kind of charts, pies, and you name it. So yeah, it was a bit quirky at first, I must say. We got some help from KX to get it there. But we haven't seen anything as powerful, especially when you have a lot of data and you need to display it very fast. I would just mention there are 3 modes in dashboards. There's a static mode where you just pull the data when you start the dashboard and nothing happens. You can still move it around, play, etc. You have the pool mode. You can get the data every 5 seconds, 10 seconds, whatever you want. So it goes to the database and pull the data again. And then you have the real-time mode, which in that case is pushed by the database. So it's pushed by KX to all the dashboard. That's very powerful. It's a bit like a multicast, and you get all your data updating everywhere at the same time. And finally, there's another usage that we don't use personally, but it's like a control center. We've heard that some people, maybe among you, use it like that. So you can apparently also push back the data. So from the dashboard, you're able to control some elements of the plant and save back to KDB, which is not something we do, but thought I'd mention it. So at the top left here, you can see the FX rate. In the middle, you have equities, stocks, and then you have various graphs moving all together. You can zoom in, you can zoom out. We'll see in the graph in a second. There you go. So it's extremely fluid. And each of those, behind each component, there is like a Q query. So it's very easy to, it makes a lot of sense. So if I click on that and go to the editor, I will see that, how do I build that graph? How do I build this? How do I build that? And you can move things around. You can change the type of graphs, etc. Anyway, thank you. Cool. So where did we get? So our vision was to create a data infrastructure and research framework that could support the demands of crypto markets. So we needed something scalable, flexible, and high performing. So what we have today is we're able to integrate data from many data sources, both batch and real time. We managed to create a nice centralized data platform, which is always up to date and reliable. And we've built a high quality research environment where we share the Q libraries between researchers. That's very important. That's back to my point earlier that you have to be able to reuse what you have. You have to, there should be only one way to extract data. You shouldn't have 100 ways to access the same data. You can add filters, yes. Anyway, so that's been very, very powerful. And then we have obviously the dashboards that we just mentioned to visualize the data. And we also have accurate signals that feed back into data quality. So it's like a circle where you keep improving your data quality and your model qualities. And finally, we're able to spin up some quant workstation, which they love, with their PyKX, and they can do all the research there. So it's still familiar to what they've done with Jupyter, but they have this extra power of using Q within that. So in a nutshell, we've got a robust, scalable, and agile infrastructure that help us maintain our market leader position in the market. And in terms of what we've achieved as a company, so we're the leading digital liquidity provider in the market. We do 24/7 liquidity. We have a diversified set of product. We do spot, CFDs, options, funding, etc. We had resilience in all market conditions, which has solidified our reputation. We've also been able to automatically hedge and price in very volatile markets. And KX really helped us there to accelerate the product delivery and response time to market change, which allow us to keep our competitive edge. Just a few examples of how we kept on with the market. And we launched some groundbreaking innovation like the first Bitcoin gold derivative. But to give you a few examples, we sustained the markets thanks to a few people here during FTX crisis, during Terra Luna. So Terra Luna was a coin that went from $85 to $0 in one day. So you can imagine as a liquidity provider, you have clients that have positions there. You're also market making, you're hedging. We had zero issues on that day. It was all handled very smoothly because of the reactivity of the plants. And finally, U.S. election was very smooth, one of our biggest periods ever. But it was almost boring because it was very smooth. There was no issues. The plant sustained the data very easily. Thank you very much. I'd like now to open the floor to any questions.